So we only have a few left, so let's try and get through these last ones in this last module here. So I'm going to jump around a little bit just to make these make a little bit more sense. So first one I'm going to talk about is saving and loading game files. Now the idea behind this is to be able to save progress. Now that progress may be progress in the game, or just may be progress as an overall basis. So you might have like a top 10 high scoreboard. In order for that high scoreboard to be persistent and be there the next time you play the game, that means it needs to be stored somewhere. So saving and loading game files allows you to do that. Another purpose of saving and loading game files is of course to save your game, how far you've gotten, maybe what your stats are and your score and all that kind of stuff. And then the next time you play the game, you give the user the option to load the game or start a new game. And then finally, another one would be lead into our next objective, would be an in-game level designer. So what an in-game level designer is, be very careful of this. This does not just mean well-designed levels, that you created awesome levels. I'm happy that you created awesome levels, but that can't be one of your objectives, because your objectives are programming objectives, not design objectives. So an in-game level designer is a designer that allows the player themselves to create and design their own levels. So you're creating a tool for them to do that. Now of course, in order for them to play their level, that means that you have to give them the ability to save that level. So that's where we come back to saving and loading game files. So you save it in some structure, and then they have the ability to load their levels either right then and there or the next time they play the game. So the next one would be animation. Now most of you have already done animation by this point, but basically in order to have animation to be an objective, it must be something that is challenging. Now if you're doing Java and you're using the Java game engine that we've created for you, animation cannot be one of the objectives for the simple fact that the tool basically does it for you. Now that being said, if you are using XNA or whatnot, animation is a completely acceptable goal because there's a lot more work and overhead involved in it. But it needs to be in more than one item in the game. It should be prevalent everywhere in the game. It shouldn't just be shoehorned in. It should be part of the game itself. So if you're going to have animation, make sure it's integrated in there. And again, animation is just the idea of simulating movement, not motion, but simulating movement of an object or a player in the game itself. Now, the last two that I'm going to talk about, I'm going to start off with integrated physics. Now, physics is a very broad term, obviously, but in video games it's used in very specific ways. Gravity, for example, acceleration. Gravity always making you fall down. Acceleration means you speed up and slow down. So just because you let go of that accelerate button or that go button doesn't mean you stop instantaneously. You decelerate. Not all games work like that, but potentially yours could. Projectile motion. This is the idea of throwing something through the air. So for example, it might be like Angry Birds, where we have like a slingshot, and that slingshot pulls back, and you have your bird in here, and as it flies through, it's given a specific velocity and an angle, and eventually it hits something. So this idea, this motion, has a specific angle, let's call it theta, and a specific speed. Those two together give you a velocity. Velocity is made up of speed and direction. And using that information, you'll be able to calculate where that bird or ball or whatever it is you're throwing is during its trajectory. And of course, as it's moving, gravity is always being applied. So eventually, gravity will overcome the vertical velocity, the upward velocity, to eventually have it coming down towards the ground again. So that's the idea of projectile motion. Now, why do I talk about that? Because when we talk about a particle system is just a whole series, thousands, hundreds of individual projectiles. So for example, let me just clear this out. You might have a projectile that's a firework, and it goes flying through the air, and then eventually it hits a point that it explodes. So yes, it's a projectile, but then when it explodes, it becomes thousands of other little projectiles that are going off in various directions, 360 degrees around that projectile. Now, it might be another game where you have a dude who's holding a gun and he shoots, and he comes and he shoots this wall that's sitting here, right there. But when the bullet hits the wall, maybe some particles of concrete fly off the wall to show that the bullet hit the wall. Now, of course, none of those particles would be going backwards because that would be going into the wall itself. They would all have to go back towards the player themselves in some various angles along those lines. So you can see how you can specify those different angles. Things like a waterfall. Waterfalls can be simulated with thousands of particles that are just kind of dropping down. Things like volcanic eruption. Things like smoke. You have a chimney. You have all these different little particles that are just kind of floating up with very little gravity applied to them. That's a particle system. Particle systems are used in video games in tons of places. Hair, cloth, fire, water, explosions, all over the place. So how can you apply a particle system to your game? So that's all of our objectives. One thing I wanted to mention though is that in the grade 11 and the grade 12 courses we do allow for the use of Unity in your games. That being said, all of your objectives must be your objectives, which means if Unity does it for free, it can't be your objective. Collision detection, animation, all that kind of stuff, that stuff is built right into Unity, so I can't give you credit for that. So you're going to have to come up with some unique objectives that will still make sense. AI would still be a perfectly acceptable objective, for example. So those are our objectives.